Clear? If it is not seen, at least you remind, ma'am, it is not seen. Okay? Not at the end of the class. Hmm? At the beginning only. Whenever you miss the PPT, you can tell me. Huh? Anyone. Okay? Is that okay, students?
Yes, ma'am.
Yes, ma'am.
Okay. So last class what we discussed? We discussed about electroplating. What is the electroplating process? It is nothing but it is a process of coating of metal with a thin layer of another metal by electrolysis process. So here electroplating process means here we require power, we require external power supply for the coating. So which metal you want to coat, the unknown metal which you want to coat, that object or that substrate, that object has to be taken as a cathode. That cathode, here we are not taking any other metal. Cathode is the object, okay, which we want to coat. That we have to connect it to the power supply, and the anode is another metal, which is a metal which acts as an anode. From this anode metal, with the help of a electrolyte, this moves the electrons, this liberates the electron. Those electrons will get coated on the surface of a object what you have taken with the help of a current. This phenomenon or this process of coating a metal on the surface of a substrate or object is called as electroplating process. So this electroplating is a process of coating metal with a thin layer of another metal by electrolysis process to improve the metal corrosion resistance. So how we can do this electroplating process? What are the principles governing this electroplating process are? The first one is decomposition potential, second one is polarization, and the third one is over voltage. First one is decomposition potential, second one is polarization, third one is over voltage. And the next, what is we will see one by one what is decomposition potential, what is polarization, and what is over voltage. So what is decomposition potential? Yesterday we discussed, right? What is decomposition potential? Decomposition potential is the minimum voltage, that must be whatever the minimum voltage is being supplied to bring about continuous electrolysis. You can see here the curve, right? If whatever the minimum voltage, this is the voltage what we are supplying, how much voltage we are supplying minimum, that is maybe minimum or extra. According to that, what is the potential deviation you are getting, the deviation in the potential because of supplying a minimum voltage or minimum extra voltage. This potential what we are getting is called as decomposition potential. So this decomposition potential based on the voltage supplied for the corrosion or voltage supplied for the coating process. This is done by using this beaker which contains a container or a vessel which contains an electrolyte. This electrolyte as immersed with an anode and a cathode, that is an object to be coated, and then these two are connected to the external voltmeter, and these are connected to the measurement of how much potential is required or how much potential is liberated, how much it is connected to the milliammeter and to the external power supply battery or a resistance to measure. So when this current is switched on, as the electrons are moved from anode to the cathode with the help of an electrolyte, you can see a deflection in the voltmeter. From this deflection, we can plot the graph. We can easily get to know how much potential is developed at this deflection. So this minimum potential, whatever the potential developed or what potential developed at a minimum voltage is supplied, that is called as decomposition potential. Understood? So the next is polarization. The polarization is nothing but it is based on the ions, based on the phenomenon or a potential developed in one particular electrode. So obviously cathode is an object, there won't be any potential developed in the cathode. So whatever the potential developed or what is the potential developed in both the electrodes, anode and cathode, and this phenomenon of developing during coating process, which is measured by using a Nernst equation, that is E is equal to E naught plus 0.0591 by n log of Mn plus. So what is polarization? It is an electron phenomenon, electrode phenomenon. The electrode potential is determined by the Nernst equation, and this polarization depends on the factors. What are the factors involved in polarization is, one is nature of electrode, electrolyte concentration, temperature, conductivity, rate of stirring, electrolyte and product formed at the electrode. So these are the, based on these factors, the polarization depends on this. Okay. The next principle is over voltage. So what is over voltage? Over voltage is nothing but it is defined as the excess, how much excess voltage we are supplying, how much excess voltage we are supplying, that has to be applied on the, how much excess voltage is supplied, that has to be applied above the theoretical decomposition. Say suppose during decomposition or during coating process, some theoretical potential is developed, some theoretical decomposition potential is developed. Apart from that, how much excess of potential we are applying, how much excess of voltage we are supplying, how much above from this theoretical decomposition potential, that excess of voltage is called as over voltage. It is expressed in terms of eta, experimental decomposition potential minus theoretical decomposition potential. Remember, theoretical decomposition potential always is, it is the same, it is constant. What experimental decomposition potential, it is higher less to theoretical decomposition potential. So the difference gives how much excess of voltage we supply to the decomposition for the potential to take deviation. So that is, for to explain this, I have given simple example here for a water, electrolysis of water using platinum electrode. So platinum electrodes we are coating, so platinum electrodes we are coating here. These platinum electrodes are theoretical, what is the theoretical decomposition of platinum electrodes? It is 1.3 volts. Platinum electrode decomposition is 1.3 volts. And when you coat experimentally, on manually, if you coat, the whatever the decomposition potential measured during experimentation is 1.7. So the difference is 4.4, not 0.4. So 0.4 volts are difference. So this 0.4 volts difference is the over voltage. How much, this much excess of voltage is applied, that much excess of voltage is called as over voltage. Understood? So this over voltage depends on the factors. One is nature of electrode, nature of product, and current density, temperature, and rate of stirring. So these are the factors which depend, based on these factors which are involved in the over voltage electrolysis process. Understood? Is there any doubt in all these three principles? Students, any doubt here?
No, ma'am.
No, ma'am. Any clarification you need, you require for this principles? Okay, shall I go to the next electroplating topic?
Yes, ma'am.
Yes, ma'am.
Yes. So electroplating is a process. Electroplating is a process of electrolytic deposition of metal, electrolytic deposition of metal on the surface of a metal or a substrate. I am saying substrate, nothing but object. This substrate may be another metal or a polymer or a ceramic or a composite. Anything we can coat from the other metal. So either we can, cathode may be a polymer, maybe a metal, maybe a ceramic, or maybe a composite. All these things can be coated by using another metal. So how this coating is been, see here I have shown you the diagram for electroplating bath. It was so much not required to write the diagram and all. Here I just represented here to understand, better understanding. So this is what you are seeing is, this is a container a bath composition has to be prepared. See, directly we cannot take one anode and we cannot take an object, connect to the external test supply and connect, and directly we cannot coat, right? So we need to prepare the device. You need to prepare the bath solution. You need to prepare the cathode. You need to prepare the anode. You need to, what are the reactions has to be taken place, that you have to monitor. You need to connect it directly to the voltmeter. All these things you have to set up that is pre-setup you have to do before plating process to be done. So what is that precautionary measures you have to take, like pre-set, how to set the electrolytic bath solution, that I have explained here. See here, this is the container which contains an electrolytic solution. One second. Which contains an electrolytic solution and electrolyte, usually we call it as an electrolyte, and this is the bar which is the anode. This is the anode bar, and this is cathode bar. This is cathode bar. This is cathode. Cathode bar is nothing but object or a subject which we want to plate. This is an anode, a plating tank. We usually call this as an electrolytic bath solution tank or a plating tank. Is an anode which is connected to the external batteries, and which work the cathode. You can see cathode or object which is placed at in between. It is placed and which is connected. The red color, you can see the wire connection. It is connected to the cathode at the negative terminal. Positive terminals are anode and negative terminals are cathode. This cathode negative terminal is connected to the object or plating which we wanted to coat. That substrate is taken in between, and above this side, left side and the right side, you have fixed the anode bars. Which anode bars? Where the electrons are starts moving towards the cathode. Once it is fixed, all the three objects are fixed, are immersed into the container which is called as tank or a bath, electrolytic bath tank. So how this electrolytic bath solution has to be fixed? So this electrolytic bath is a plating bath. Usually this is a plating bath contains, usually this is a plating bath contains solution for plating process. It is normally mixes with the metal solution, other electrolytes. See, usually it contains a metallic solution. Electrolytic electrolyte means what? It contains a metal solution, right? It contains metal, a mixture of metal on ion solution, electrolytes, completing agents of various organic additives. It also contains additives. So electrolytic, this tank, whatever the tank you are seeing here, this tank contains an electrolyte. That electrolyte also contains some organic additives, extra additives can be added to improve the nature of deposit. This is how electrolytic bath solution has to be preset. Then next is cathode. Cathode is nothing but it is a substrate to be plated. Substrate means what object you want to plate, that has to be taken as a cathode. So this cathode plate is made cathode and suspended with the separate bars. This cathode electrodes are placed in the electrolytic bath solution. So either a substrate or object can be placed inside the bath solution. Anode is the metal which is to be plated, or a metal is made as anode. Anode is to form a rod and plates are pellet. The anode is enclosed inside the anode bag and retain impurities. So this is one anode bar which you have to take. With the help of anode, you can coat the substrate or a cathode. So what is the reactions taken place here? The reaction taken place here as at cathode, you can see there is a reduction, and at anode there is a oxidation. Usually what is an oxidation process? The metal undergoes oxidation to liberate the electrons, and reduction means metal gains an electron to under reduced form. So in your syllabus you have electrolytic process of, so first one is chromium, you have one is decorative chromium in your syllabus you have, and the other one is hard chromium plating. So both are same. The only electroplating of chromium is there in your syllabus, but in your electroplating of chromium, two methods you can go. One is for on the application basis, you can coat either to a decorative chromium or to a hard chromium directly. So method of what is this electroplating of chromium? It is a method of depositing a layer of chromium on an object by electrolysis is called as electroplating of chromium. A method of depositing layer of chromium. So what we are doing, we are depositing a chromium metal on the object. That is called as plating a chromium metal on the object as a coating process. One is we can do, what are its applications? It is used as objective purpose, corrosion resistance, decorative purpose, increases the hardness of the surface. There are two types of plating. One is soft chrome plating, that is decorative purpose. Other was hard chromium plating for engineering applications. Based on the applications, we can coat the chrome. We can coat the chromium on the surface. So based on the application means, once if you want to coat the chromium on an object for a decorative purpose, you can coat. If you want to coat the chromium on an engineering application like machine parts or automobile parts, you can coat with a hard chromium. So how it is being done? What is that decorative chromium plating? Decorative chromium plating is nothing but it is a thin deposit of 0.25 to 0.75. Remember this. It is a thin deposit of 0.25 to 0.7. The thickness of this is the thickness of the chromium which is applied over a object, copper, nickel or nickel. Any copper utensils or any copper ornaments or any nickel, based on that applications you can coat. What is the thickness of chromium you have to maintain here is 0.25 to 0.75. So this coat gives a pleasing look and non-tarnishing nature in the plated article. So what is hard chromium? Hard chromium plating is a depositing of chromium. The thickness of the chromium is 2.5 to 2.5 to 5 300 micrometer. It is 2.5. So compare between the decorative chromium and hard chromium. Here the thickness of chromium is more, hence it is called as hard chromium plating. Here the thickness of chromium is less, hence we call this as decorative chromium purpose. Understood? So now what you have to do is write only the definitions in the previous. Here also you write method of depositing. Write this electroplating of chromium. You write electroplating of chromium. Write the definition. All of you can see the slide, no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So write the definition. Electroplating of chromium, method of depositing chromium, and types of plating. That up to there you write. Sir took 1 hour completely in class. Hmm?
Yes, ma'am. He was taking attendance, so it was getting late.
Okay. You did not tell, sir, that you have another class. Oh, here it is gone. Sorry. Written. Finished? Don't write these two, just write up to here. Okay. In the next slide, I'll explain how to take the chromium process. Written? Yes, ma'am.
Yes.
Till here you have written, no? Till the hard chrome plating for engineering application.
Yes, ma'am.
Anybody has to write? Will I go to next slide? Okay. Here, so what I explained here is here the pre-treatment. Pre-treatment before coating the object, you have to clean the machine. You have to clean the object. You have to set the electro bath solution. You have to set everything. You have to set the temperature. You have to set the bath compo. You have to add the chemicals and you have to set everything. That is called as pre-treatment. So what is that pre-treatment, pre-setting up the before the application of the electroplated coatings? It is essential to clean the surface, your cleaning process. It is essential to clean the surface of a base metal. The impurities present on the surface like grease, oil or oxide layer, dust, etc., which can be removed by solvent cleaning, alkali cleaning, or mechanical cleaning. Then chromium plating is done under the following conditions. How it is being done? See here, you have to remove first whatever the like this object is there. You have to clean that surface. I'll give you simple example. Before painting on the wall, see you have to as after immediately after construction, you cannot paint the wall as it is, right? You have to set the wall. You have to apply one coat of. You have to make. You have to remove the dirt particles. You have to remove any pits are there, any holes are there. You have to set the wall first. Then only you can apply a final layer of a paint, right? Similarly here, before coating any metal on the object, you have to clean the surface. Anyways, like what are the pre-treatment process? You can clean by using solvent. You can clean by using alkaline solutions, or you can clean by mechanically. Mechanical means scratching, etching, or removing the dirt particles by hand or by using any brush, or that is called as mechanical cleaning. First, you clean the surface, set the surface for coating. After that, how you have to coat? You have to prepare the composition. See here, I have two tables. Three tables are there. In the first column, I have mentioned what is the bath, like what is the bath sorry, in the first table here, I have mentioned the bath compositions, how you have to set the bath. That is in the first column, what is anode, what is cathode, what is the Kabat compositions you have to add chemicals, what is the current density you have to maintain, what is the temperature you have to maintain, how much current efficiency it is required, what are its applications, what is the reaction, anode reaction, and what is the cathode reaction. Understood? So now if you look at the decorative chromium first, decorative chromium, it is insoluble anodes. What is the anode you are taking? In decorative chromium, we can take like lead and tin, the combination of lead and tin, or lead and the coated with this lead oxide, which is coated with the lead oxide. The combination is with the lead. It can be insoluble anodes. These are insoluble anodes we are taking. So what is the object, the cathode you are taking? Cathode you are taking is object to be plated. Any object, what you want to plate, what you want to coat, that object or that substrate you have to take. So what is the composition of electrolyte which is taken in the tank? that is 100:1. 100:1 means chromic acid and H2SO4. If you have taken 100 ml of chromic acid, in that 1 ml of 100:1 ratio, you have to take the between the chromic acid and H2SO4, that is concentrated sulfuric acid. So what is the current density you are maintaining? The current density you are maintaining is 145 to 430 angstroms per ft square, that is per feet per square. That is the current density you have to set up. You can set in the thermostat. You can set in the electrolytic bath container. What is the temperature you have to maintain throughout the process? 45 to 60 degrees Celsius. At a current efficiency of 10 to 15%, the chromium, that it can be plated. The chromium, from where chromium it is plated? Chromium from the electrolyte. Chromium from the electrolyte, because electrolyte contains what? Chromic acid. From this it is coated on the object with the help of a anode. It boosts the reaction. So what is the application it is used? It provides a durable, good furnish automobile surgical instrument. What is the reaction in both decorative chromium? First, we will see what is the how to set the bath composition. Similarly, in case of hard chromium, you have to set the anode. Anode here also insoluble anodes like lead and tin and lead and antimony. This which is coated with the lead oxide. Both are same in both the cases. Cathode is same, that is object to be plated. What is the bath composition? Here also 100:1 chromic acid and H2SO4. Here only changes here is, in case of decorative chromium it is less current density, but in case of hard chromium it is more. What is the current density here? Because you have to maintain the thickness around 2.5 to 300. Hence we have to maintain the increase the current density to 290 to 580. So what is the temperature? The temperature can be 45 to 60 degrees in both the cases. The current efficiency here is 17 to 21%. So what are its applications? It is extensively used in industrial and engineering applications. So what is the reaction taking place here? The reaction is here because your anode you are taking, anodic reaction is, it is coated, since it is coated with the lead oxide. What is the water, the moisture which is present in the electrolytic bath solution? It liberates the oxygen, liberation of oxygen takes place, and also H plus ions and electrons. And these electrons, whatever the electrons are liberated from this anodic reaction, which is gained by the chromium, that is Cr3 plus. From where this Cr3 plus is contains? The Cr3 plus ions from the chromic acid. Chromic acid is present in bath composition, electrolytic bath composition. So this chromic acid bath composition contains this Cr3 plus. And what is the electrons here? This is the electrons gained from the anodic reaction. So here this chromium is liberated. Whatever the liberated chromium in the cathode, it is just opposite, is this sits on the surface of a object to be plated. This is how decorative chromium and hard chromium is plated by electroplating process with the help of a current, with the help of a external DC source. Understood? Is this clear? So what you have to do is write that table. Write that table fast. Write this table. I'll take the attendance. Write this table fast. Any doubt here? Anything you did not understand in this bath coating process? Students? Hmm? Any doubt?
No, ma'am.
After writing, tell me. I'll take the attendance and then you can leave. Written?
No, ma'am, not yet.